Yep, and it is recording as far as I can see. So, hello everyone, good morning. Thanks a lot for coming. I'm really happy that we have good attendance. I have 20 people now, as I can see, and that is amazing. That's exactly what I wanted. That's why I decided that I wanted to stream this instead of just pre-recording, because I don't know, I just think that talking to myself is kind of depressing. So I prefer to talk to you instead. And hopefully it works. Let's see. And again, I will say this a million times. Raise your hands if you want to ask anything. That's absolutely fine, and that's exactly what I want actually. Now, our lecture will be basically composed of 4 parts. Okay. So sorry, I don't want to repeat myself too much, but there are 3 people with the microphones that are not muted. So that's Stanislaw, Dominic, and Badis. So I would just ask you, please, if you are not going to say anything, please mute the microphone just to try to keep the recording clean. Thank you. Now, so okay, so our lecture is going to be basically 4 parts. The first one that I'm going to start now is the Python intro. So for those of you who already know Python, this will be boring, but I will try to be very efficient because we don't have much time and we have a lot of stuff to cover today before 12, or maybe like a little bit after 12 if it's okay. So I'm going to start with Python, basically because I mean I would love to think that everyone already knows Python, but I know that's not the case because I asked you in that form, and most of you said you have very little to no knowledge of Python. I think it was, I don't remember now, but I think it was about like 30% of you said, yeah, I know intermediate or more, and 70% said I know nothing or very little about Python. So then that's why I decided that, yeah, this part has to stay. It would be better if we could take it out, because then we would have more time for the rest. But unfortunately, I think it's not possible right now. Anyway, this is not a very like extensive Python tutorial. Okay, there are literally millions of those out there. And I'm not sure if the links that I gave you already include some of them, but probably they do. If not, I can drop a couple of links for you later. But again, this is just like bare minimum that you need in order to understand the rest of the lecture, okay? So don't get like too attached to this in terms of, oh my God, I don't understand anything. This looks so complicated, blah, blah. Don't worry about this. You're going to have to learn Python, but it's going to be not today. Like you're not going to learn Python in half an hour today. Okay. Just try to relax and follow it in like the bare minimum. And if you really cannot follow it, then raise your hands, ask questions, and we can take them. But just don't expect that you will be a Python programmer in the next half an hour, because of course you won't, right? So Python is a general purpose programming language. It's great in general, but also it's really like what makes it shine is when you use some popular libraries like NumPy, SciPy, Matplotlib, scikit-learn. This is what really makes Python great. It's the amount of stuff that the community has contributed and the amount of libraries that you have. In my opinion, I mean, of course, this is my opinion. It's not that the language itself is amazing, but the environment of libraries is what's, in my opinion, really amazing, especially for data scientists. Okay, so let's take a look at the basics of Python. And always remember that if you want to follow this tutorial, you need Python 3.6 at least, because there's a couple of things here that are new. So we're dealing with new Python here. We're not going to deal with old versions. Now, if you've never seen a Python code, this is then your first Python code, and congratulations, you've just been introduced to Python. And oh yeah, and one small thing that I just have to mention is that everything we're going to do here in this lecture is going to be on notebooks. So what's a notebook? A notebook is just like this thing where you can write reports in Python, so to speak, reports, where you can mix a little bit of text and a little bit of code. So this, for example, this here that I'm pointing at, this is a cell. This is a cell that contains code. So when I write code here, then I do Shift Enter. This code here is executed and I see the results down here. So these are the results of this block of code. This is by far not the only way that you can run Python, okay? Like you can run Python just like everything else, every other programming language that exists. So you can you have IDEs, you can just write your own scripts and run them on the command line, or there are some online programming environments that you can use. It doesn't matter. It's just that I chose for this lecture Jupyter Notebooks as a way to show you Python and everything else because I can mix up text and code and then run the code, and then later I can give this to you and then you can run this yourself. You can play with it, you can change things. So it's just to make sure this is just the my chosen way of presenting the lecture to you, okay? But anyway, this is your first Python code if you've never seen Python. And basically, I'm just assigning the number 3 to the variable x. Like, of course, I expect that you have done some programming before in any way, right? And I hope that at least, like, I won't be touching on super basic stuff. So x equals 3, basically, like, yeah, I'm assigning the number 3 to the variable x. And then I'm printing x here, then you can see 3, obviously. And then I'm printing the type of x here. So a couple of things to notice here is this. First of all, print is a built-in function. Okay, so again, I hope that you guys know what a function is. So you don't have to import it. You don't have to include any kind of a library or any kind of module or anything in order to print something like this. Okay, it's a built-in function, as we say. There are lots of them in Python to do like all kinds of things. And in this case, it's for printing the variable. Here, I'm printing the type of x. So type is, again, another built-in function in Python. Again, you can call it anytime. It's in all Python distributions. You don't have to include anything. And basically what it does is it tells you the type of the variable, right? And then here you can see it's the variable x is of a class int. And an interesting thing here to notice is that in Python, everything is an object. And unfortunately, again, I'm not going to go into object-oriented programming. I hope that you know what it means. If not, then obviously this is not the place to learn. So, but anyway, if you know what object-oriented programming is, X is an object and the class is int. And that's interesting to notice here is that this is not a basic. It's an object like anything else. And in Python, everything literally is an object, even an integer. You know, so some languages have kind of a mixed object and how do they say, like, this basic types that are not objects. But in this case for Python, everything is actually an object. So that's why you see this thing here. But anyway, it's an int, right? And then you can do all kinds of operations. Again, I'm just gonna gloss over this because obviously in every programming language you can do this exact same thing, and you know, addition, subtraction, multiplication, blah blah. I just wanted to show you that in Python this is really simple. Like there's literally no frills. It's just x plus 1. That's it. You don't have to specify types. You don't have to cast. You don't have to do basically anything. It's in Python. It's, as you will see probably as we go, is usually like takes the approach of just keep it as simple as possible. So x plus 1 is just x plus 1. That's it. One thing that might be interesting to notice is that, for example, if I say y equals x divided by 2, and then if I print y and if I print the type of y, you can see that the type is now a float. So it's a floating point number. It's not an integer anymore, even though x was an integer, right? You can do integer division by putting 2 slashes like this, and then you get 1 instead of 1.5, because then it's the closest, it's the rounded number. not the round and int, right? And exponentiation and so on. So I mean, this basic stuff. And then you can also assign a number and like do an operation at the same time. So x plus equals 1 is the same as x equals x plus 1. Again, you have that in many other languages. I'm not gonna keep like talking too much about this. The only thing I want is to note for you to remember is that there is no like x plus plus or x minus minus as you have in many other languages. In this case, you don't have that. So the closest you have is just x plus equals 1, right? And I hope the interface here of the notebook is straightforward, that you understand that when I have a cell like this, I execute the cell and then I see the results here. For example, I could add another print here, like my keyboard is not. Yeah, I could do something like hello, and then you will see hello down here because I just re-executed this cell after writing this. So I hope this is straightforward. If it's not, please raise your hand and then I will try to explain it better. But anyway, these cells are all executable. You can later, when you get the notebook, you can play with it and see what happens. Okay, so then we come to Booleans, which are very important. Basically, in Python, you have true and false with capital letters. Right? Okay, don't forget this. I think this is, if you're coming from JavaScript, you may get confused a little bit because in JavaScript you have like lowercase true and lowercase false. In Python, you have uppercase here. So keep that in mind. Okay, these are not strings. These are not like a string where it's written true. This is like a constant. This is built into the language. It's part of the language. Okay, so this is true and false. It's not a string because it doesn't have, you know, quotes like this. So it's actually Booleans. And again, I'm just printing the type of T so you can see it's of class bool. It's a new type here that we didn't have before. So true and false, that's all you need to know about Booleans. And then of course you need operations. So for example, if I print T and F, then I have false because T is true, F is false, then of course true and false is false. So, and I just notice here that you have, instead of having those weird symbols like you have in C or Java or JavaScript, what you have in Python is actually English. So it's and, or, not, or, okay, and then you have different here, but I guess writing different in full would be too much. So T and F, T or F is true because true or false is true. Then you have not true, so that's false. And then you have true, different than false, true. Yeah, that's true because they're not the same. And basically, this is how you build any kind of Boolean operation or Boolean expression in Python. And of course, you can put them together and make those more like complicated expressions, but this is the basic. And of course, that leads us to the if, because if, you know, uses Booleans basically. So if true, print okay, and then of course we see okay. And you can see here that there are a couple of things here to notice that are very important, that are really like basic building blocks of Python that you need for everything else, which is, first of all, that you have these little, well, so no, you don't need to use parentheses like this. You can do that. That doesn't matter doesn't change anything because it's just parentheses, but you don't have to. So as you can see here, you can write it a little bit like, almost like English. And you don't need the parentheses, but you can do the parentheses if you want to change the priorities of the operations and everything, like you do in every other language. But what I want you to notice here, first of all, is this thing here, this colon here. This is very important. This is everywhere, as you will see later. This is the first time maybe that you're seeing this, but it's that's how Python marks the beginning of a block of code. Like for example, in JavaScript or C or Java, you would have something like this, right? If you ever programmed anything else, then you might, well, actually you would have something like this in JavaScript or Java or some other language to mark that there is a block of code here, right? start with a bracket here and then you end it with another bracket. But in Python, you don't need that. In Python, all you need is just this thing. That this block, so this says, okay, a block of code is coming. And then you need this indentation here. This is not optional, okay? This is probably one of the things that are more awkward about Python than in any other language. I think people usually get confused with this. Indentation is not optional. Your whatever your interpreter is that you're running Python, it will complain if it doesn't see this indentation, because this is what kind of shows Python that there is a block of code here. Okay, this is what tells, look, print is actually a block of code for if. It's not, because if it was something like this, then this would say to Python, this would tell Python that if and print are basically at the same level. So the print is not inside the if as it should be, okay? So indentation, not optional. Remember this. And if I had another if here, like this, then I would need more indentation like this, more indentation. And again, if I had another one here, I would need more indentation, and so on and so forth. This is not optional, okay? And then you can, of course, use those Boolean operations here to do stuff here. Like, for example, if I say, if T and F print okay, then I don't get any results here because T and F is false. So, of course, this is not true, so it's false. So then we could do something like this, not okay. Then it would say, we would see not okay. Okay, so if true and false, okay, that's not. So else, print not okay. So again, colon here, again indentation, not optional, and then basically you write this like this. And I kind of like it. I mean, you would have to do indentation anyway. If you don't do indentation, then your code looks horrible. So I guess why not just make it a part of the language? So that this works. Yeah, now we're coming to strings. Again, I'm just gonna gloss over this. Please, if you think I'm going too fast, let me know. But really, I have no option here. We have so much to talk about today, and so much more interesting and more important things that I just cannot waste time on this. Okay. So strings, you can basically use simple single quotes or double quotes. Doesn't matter. It's exactly the same. And when I say exactly the same, I mean exactly the same. Maybe there are some corner cases in the future when you're doing advanced stuff that you might run into. But for now, like for 95% of the stuff that we're going to do, they're all the same and it doesn't matter. Okay. And as you can see here, I'm printing the string H, which is hello. So it says hello here. And then you have another built-in here with function, which is very, very, very useful, and you will use it basically like millions of times, which is the length. So you call lang, or not length. I mean, it's this length, but it's called len. So you call len function, and then you give it like something here. In this case, it's string, and then it says 5 because there's 5 letters: 1, 2, 3, 4, 5. But as you will see later, this len here can be used with many things like lists, arrays, dictionaries, and everything, and it will always give you the length of the thing that you ask for. It doesn't matter here exactly what it is. Anything that has a length will have, you know, its length computed here, shown here. Sorry. So len, built-in function, very useful. Can also be used with Lisp. We're going to see that later. And then you have some stuff you can do with strings, like for example, concatenate strings using plus. You know, so H is hello, then I concatenate it with one space here, then I concatenate it again with the world, and then it prints hello world, HW. And now, of course, I assign this to the variable HW, and then it says hello world with a space in between because I just concatenated everything. Simple stuff. Very, I mean, it's like it's the same in most other languages, I guess, with a plus. Then we have format strings, which are also very useful. Sometimes you have variables that you want to put into the string, and you want to reuse a certain string with different values. Sorry. And in this case, this is a little bit like as printf or printf in other languages that you might have worked with. And I won't go into that. If you don't understand this, take a look at this later. It's not like super important anyway. It's just something that helps you to, you know, build some interesting strings. But basically, this means like this is a string, this is another string, this is another string, this is an integer. And then afterwards, you actually give the variables that you want to replace into the placeholders, like HW12. So it says hello world 12, whatever that means. But basically, these are placeholders, and then you fill the placeholders with the variables that you put afterwards, like this. Okay. Not super important, but anyway, interesting to know. Format strings. This is another type of format string that you can, yes, I will, just a second. This is another format of f string that you can also use. This is new to Python 3.6. And I will take Maddie's question now, please.
Hey, can you hear me?
Yeah, I can.
Yeah, I wrote the question on the chat.
Ah, you wrote this. Okay, so implement a class. Does it inherit the len and print and other functions? And I will read the question so that, you know.
All right, yeah, sure.
This, yeah. So if we implement a class, does it inherit the len and print and other functions and can use them arbitrarily? Or do we have to implement something like an iterator as in Java? Good question. First of all, the class itself does not inherit len and print, because len and print are built-in functions from Python. They're not in the class, so they're not class methods. They are built-in functions in Python. But at the same time, you are correct that you need to implement something like an iterator as in Java, because or else, like, how could Python compute the length of something if it's a custom class, right? So I will not get into that, unfortunately, but yes, you would have to implement a specific type of method in your class if you want your class to be able to be passed into len.
Yes.
But unfortunately, we don't have time to go into that.
No worries. Thank you.
Mm-hmm. Yeah. So yeah. So then this is another type of format string, which says starts with an F here, as you can see, and then in this case the difference is that sorry, something happened here. Yeah. In this case, the difference is that you put the variable inside the string like this using brackets. Okay, so instead of putting it afterwards like we did here, we just put them straight into the string. So for example, here I'm saying, you know, x times 10, w in an f string. So it says 80 because x was 8 the last time we checked. I don't know. Then you can, as you can see, you can do some simple operations even inside here. Or simply put a variable like this, and it works more or less the same as the one up there. But in this case, you actually like put the stuff inside the string itself. So I guess it's just it's just a design thing. I mean, whatever works for you, whatever is better for you when you're writing your formatted strings, you can use both. It doesn't matter. And then string objects have a bunch of useful methods. So you can call, so for example, as equals hello. So this is a string that I set. And then from as, I can call some methods like as.capitalize. And now, connected to Maddie's question, this is not a built-in function. Okay, it's a different thing. This is an actual method from the class string. So again, I'm not going to go into object-oriented. I'm hoping that you know a little bit of object orientation, but basically the difference is if you see, like, for example, if you compare with print is a built-in function that comes with Python. You're not calling it, you're not doing something like as.print. You're just saying print. That's a built-in method. But when you do as.capitalize, then basically you're calling a class method or in the object as, which is a string. So it's a little bit different. And then there are like a lot of different class methods from the string that you can call. Like as.capitalize makes the first H, you know, capitalized. Then as.upper makes the whole thing capitalized. right justification with 7 places, center, blah, blah, replace something with something else, and so on. I mean, there are lots of stuff you can do. You can take a look at the documentation, and then you will see, you will find more stuff. All I wanted you to know from this is that it exists. It's there. You can take a look, and you will find like lots of stuff to manipulate strings. And the important part here is that strings are immutable. So you cannot change a string, like you cannot change as in place. Every time you change the string, like by doing these things here that you're seeing, like capitalizing, making it uppercase or so on, actually what you get is a new string. Okay, you get like a copy that is changed, so it's another string, because strings are immutable. So basically every time you do this, you're creating a new string. It doesn't matter really, it's very fast. Python handles it just fine. It's just a technical detail that you have to know, because as you will see later, lists are a little bit different. So you must keep that in mind in many cases. Just remember that everything here is actually returning a new string, because the string itself is immutable, it never changes. Now, okay, these are like the basics of the basics of the basics, and now we're gonna go into something that's actually a little bit more interesting, which is data structures, right? I hope I could just have skipped all the way to this, because this is much more interesting. And the basic, like the most important data structure of Python, well, in my opinion, probably the most important, are lists. Okay, so lists are like arrays or vectors in other languages, but in Python they call them lists for whatever reason. In basically, the way you can create a list is by using square brackets like this. So I just created a list here of with the numbers 3, 1, and 2 in this sequence. So the first one is 3, the second is 1, and the third is 2. And then as you can see, I can print them. For example, I can print access, and then you see this thing here. I can access specific elements of the list like this. So I want the third element here is actually instead of the second, because it starts from 0. So if I say access and I use 2 here, it means the third element. So I see the number 2 here as a result. Again, I'm not gonna focus on this, because this is the same as in most languages, so I guess it's familiar. One thing that's not very familiar, maybe, it's negative indices like this. So negative indices count from the end of the list. So -2 basically means the second last element, let's say, because this would be -1. There is no -0. So in this case, it starts from -1. So this one is -1, and this one is -2. And that's why you see the number 1 here. So if I run this, I'm seeing, oh, I can do, like, if you want to see, I can change this to -1, and then you can see now the number 2, because this is -1. And -3 would be -3 would be the number 3, because it's -1, -2, -3. Okay, so this is, I guess, a little bit new. I don't remember any other language that has this, and this is super useful, because if you wanted to do it some other way, you would have to do something like, I want the last element. Oh, so I take the length of the list, and then I remove 1, and then I use that, and then I see the number 2. But of course, the alternative here is much easier, right? So it's much easier to write this way. And then lists can contain elements of different types. As you can see here, I just mixed up numbers and strings. It doesn't matter. Lists are lists. Python is very flexible. I think that's one of the reasons why it has been adopted so much. It's really flexible. So you can put anything into a list. Doesn't matter. Same thing here. I added a new element to the end of the list, and then you see 3, 1, foo, and bar. And again, the way that I'm adding an element here to the list is by calling this method append on the list. So again, this is not a built-in function. This is a class method from the list class, and that's why I'm calling it like this, xs.append. Okay, instead of something like append and whatever. This doesn't exist. okay? Just to make sure that you guys see the difference here between a class method here and a built-in function here, okay? And as you can see, notice above the lists are mutable. So they're not like strings where every time you do something with a string, you get a new string. In this case, every time you do something with a list, you get the same list, okay? Unless you explicitly want to have a new list, so you can like clone or copy your list and create a new list based on the current one. That's not what's going to happen. Most of the time, what you're doing is you're actually changing the list itself. So the reason why you must remember this is that when you're, for example, you have a list and then you call a method or a function and you give your list and then you change it, you're actually changing the same list that was outside of the function. So you have to remember that, because since lists are mutable, you must pay attention to that, okay? And again, millions of things you can do with lists. This is just the basics. The details you can find in the documentation. Please check it out later. But for now, that's what we need to know. Now, tuples are like lists, but they're, again, immutable. So you cannot change a tuple once you've defined it. So for example, let's call this tuple T. Let's say we define this tuple T as being 5, 6. And notice here that a list uses square brackets and a tuple uses parentheses, okay? Different thing. It looks almost the same, but it's a different thing. So for example, I define here a tuple 5, 6. Then I print the type of the tuple. It's tuple, class tuple. And then you can still do indexing like this. The first element of the tuple T is 5. Exactly the same. You can, all the indexing that we did on top here you can do the same. However, if I try to assign a new element like this, so I want the first elements of the tuple to be 1, then I get a type error. Tuple object does not support item assignment. So once you define the tuple, that's it, okay? Those of you who know Python will actually say, well, you know, there are exceptions to this. We're not going to go into that. But just let's assume 99% of the time, a tuple is immutable. You cannot assign a new element to the tuple like this, period, okay? So it's useful in some cases. Some people sometimes ask, yeah, but like, why should I use a tuple instead of a list? Or why should I use a list instead of a tuple? Why not just have lists and period and forget about tuples, right? There's actually, it's most of the time is actually more like a conceptual thing, to be honest, because when you think of a tuple, you're thinking of a description of something that has specific fields. Like for example here, the student one is, his name is Sven. He is 18 years old and his grade was 85.93 or something, I don't know. And then the student number 2 is called Gunilla. She's 76 years old and her grade was 74.32. So in this case, in this tuple, each of the positions, the first one, the second one, and the third one, they have meaning, right? Like the first one is the name, the second one is the age, and the third one is the grade. It's not like a list. A list is more like this variable collection of things. So you can make a list called students, and then you can put student number 1 and student number 2 in it. And then you could put more and more students. You could have 40, 50, 100 students in this list. Because conceptually, a list is supposed to be like this. It's something where you, some collection where you put things into it. While a tuple is not supposed to be something that you change. It's supposed to be something that is like a description of an object, okay? Conceptually. This is usually how you separate between tuples and lists, okay? Again, technically speaking, you could use a list to do something like this. Nothing would change. You could still have the name, the grade, the age, and the grade. This could be a list. It wouldn't really like be technically different, other than the fact that the tuple is immutable. But conceptually, that's how we usually consider things to be. Okay. Now, slicing. Slicing, in addition to accessing list elements one at a time, Python provides concise syntax to access sublists. This is very nice. This is a very interesting function from Python. So you can use colons here to determine how to slice the list. So for example, in this, I mean, I want all the elements between the second and the fourth. And when you do something like this, the first one is included, but the second one is not included. So here, what you see is 2 and 3, because you have 2 and 3, and then when it gets to 4, 4 is not included, and that's it. The slice is over. You can omit either one of them. Well, yeah, actually, you can omit both of them. But anyway, if you omit, then this means it goes all the way to the end. So I want all the elements starting from the second one until the end. And this means I want all the elements from the first one until the second one, but not including the second one, right? So that's why we see, for example, here, 2, 3, 4, because it starts at the second one and goes until the end. And here we see 0, 1, because it starts at the first one and stops before the second. So 0 and 1. And then if you do something like this, then nothing changes. You get a slice of the whole list, because you're saying basically, I want everything from the beginning to the end. So what's the point, right? It doesn't matter. So it's basically the same. And you can still use negative indexing like you can normally. So here it means I want everything from the beginning until just before the last element, because -1 is the last element. And since this one is not included, then you don't include the last one, and then you see something like this: 0, 1, 2, 3. And then there's also this possibility of putting 2 colons here, and then the last thing is a step. So for example, here I'm saying start from the second element, go until the end of the list, but skip 2 elements at a time. So then I see 1 and 3. I'm not gonna go into details here. It's something that you guys can experiment with and find use cases for this, but I just wanted to know that it exists. Oh yeah, and the interesting thing here is also that you can assign things. So for example, I can say, this is very interesting. I can say, okay, the list nums, if I take the third element until the fifth element, just before the fifth element, so it's basically the third and the fourth element, I want to replace them by 8 and 9. And then what you see here is 0, 1, and then 8, 9, and then 4, because I replaced these guys here. And as you can see, the list is mutable. So I changed the list in place here. It's still called nums. It's not a new list. Okay. So 0, 1, 8, 9, 4, because I asked to change the list like this. This is very, very powerful. Very powerful. So it's really something that it pays to learn how to do this, because it makes things like so much easier, right? Yeah. So a few of details that I said here. Forget about this for now. We're gonna go back to this later, and I will explain to you what it means. Now, loops in Python are, every loop in Python is a for each loop. So we don't have loops like we have in other languages, like it starts with int ei = 0, and then you go I is less than 10, I++, and so on. I mean, you can simulate this. You can do something like this. You can make it work, but it doesn't. It's still a for each loop. You're gonna see what I mean. So every time you're writing a loop in Python, you got to remember you're actually looping over some collection of things, even if it's a collection of numbers from 0 to 10. So for example, here I have a list called animals. I put there like cat, dog, and monkey. So 3 animals in my list. Then I say for animal in animal. So basically I'm saying I want to loop over all the animals in this list, and I want to call each one of these animal. So that's the name I'm going to use when I'm actually writing the code here in the block, right? So, and then I say print I love animal with an S. I'm concatenating the strings here. And then you can see I love cats, I love dogs, I love monkeys. So it's, this is a for each. I'm saying for each animal in the list animals, I want to say I love and then put the name here, right? All for loops in Python basically work like this. The difference is that is what comes in here. So If what comes in here is a list of strings, then you're looping over strings. If what comes here is a list of integers, then you're looping over integers. If it's a list of objects, then you're looping over objects. Doesn't matter. Everything is a for each loop. Okay, but you can simulate this thing here, this int I blah 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 I less than 10, by looping over a range of numbers. And this range here is a built-in function again. This basically says, I want all the numbers from 0 till 4 in this case, without including 4. So you see 0, 1, 2, 3. And then what I do is I print the x. So I say for each x in a range of numbers from 0 to 4, I want to print the x. So I see 0, 1, 2, 3. And I also want to print x squared. So I see 0, 1, 4, 9 here. Okay. I'm not going to go, I have to really run now because my time is up for this part of the lecture. But just remember, there's one catch here which is important to know about this, is that range 4 is not a list. Okay, in Python 3, in Python 2 it was a little bit different. In Python 3, a range is what we call a generator. It's like an iterator, okay? But the important part here is that this is not a list. This thing, it generates numbers as they are needed. For all, let's say, if we can consider this almost as being a list. The only thing you have to remember is that it's not in the memory. Like this list is in the memory, right? You put there, it's like animals equals cat, dog, and monkey. So it's there in the memory. But when you call it like this, for x in range 4, actually the numbers from 0 to 3 are not in the memory. They are being generated for the for loop as the for loop runs. It's not it's something that you will understand as you start dealing with like large amounts of values. But for now, it doesn't really matter, right? And that's the reason why I called list range 5 here, because basically by calling list on the range, I actually turned it into a list. So I go over all the numbers here and I make them into a list, because at the beginning they were not a list, they were just a generator. It's just a detail that is good to know, but it's only gonna affect you later when you're doing some more advanced stuff. One interesting thing also to do is to enumerate something. So for example, here I'm calling the built-in called enumerate, which basically means, okay, I want the animals, but I also want the index of each animal. So I want to know like the first one, the second one, and the third one. And that's why I can do something like this. I can print the index here and I can print the animal. So animal and index coming from enumerate animals, and enumerate is also a built-in function. And it's also a generator, but it doesn't matter here. One interesting thing about this call here is that you can see this looks a little bit different than the previous one, because now I have two things here. I have the index, I have a comma, and I have the animal here, right? And that's interesting to analyze a little bit, because basically what you're doing here, and this is a very strong thing about the Python language also, is that we are actually, how can I say this? Yeah, we're unpacking the results of enumerate, because the result of the enumerate function is actually a tuple. So for example, take a look at what happens down here. If I print, yeah, I'm just going to print a tuple so you can see. Look here what's happening here. This is more like a normal for loop. So I'm saying for each tuple in enumerate animals. And then I'm printing the tuple here. So we can see it's a tuple that comes with a number and a cat, and then a number and dog, and then a number and monkey, right? So I could do it just like this. I could simply use this tuple and do whatever I want. That it would work exactly the same. As you can see here, for example, I'm taking the index as being the first element of the tuple. I'm taking the animal as being the second element of the tuple, and then I'm printing it, index and animal. That works perfectly fine. However, Python kind of like gives you a hand and lets you just simply take this tuple here and just unpack it here into an index and an animal, so that you don't have to actually do it yourself like this. You just unpack it like this and you say, okay, every time I get a tuple here, the first element is going to be called index and the second element is going to be called animal. and then I can just use them here in order to, it's just to help you make your code more readable. Again, don't get too attached to this. You're gonna have to learn it, and you will learn it anyway. It's just good to understand what's happening here. Just remember that this is an actual tuple. It's that is being unpacked into two variables, index and animal. Okay. Yeah, there's also a while loop if you want. Most of the time, to be honest, personally, I very rarely use it, but you can use it if you want. It's the same, follows more or less the same structure. I have a list here, for example, and then I say while the length of my list is larger than 0, I call this pop method from the list, which basically removes the last element and returns it. So I pop 16, I pop 8, I pop 4, I pop 2, pop 1, and then when there's nothing else to be popped, then the length of my list is not larger than 0 anymore, then the while is over, right? But the structure here is basically the same. You have while, and then you have something here, and then you have the colon and the indentation, which is not optional, okay? Which one should you use, while or for? Well, it's up to you. It's depends on what you want to do. Dictionaries are also very important. A dictionary is basically like a map in Java, or in JavaScript. I guess in JavaScript they're called objects, or also dictionaries sometimes. But it's basically a way to assign a value to a key, right? So it's a key. There are pairs of keys and values. So for example, in this case, I'm defining a dictionary here. You use curly brackets for this. And then you have, I want to say that cat is cute and dog means furry. So when I try to access it like this, D, and then I give a key here, cat, then I see cute. And basically it's the same way that you can index a tuple or a list. The difference is that the key here that you're using is not an integer, it's a string. So you can, it's very flexible. You can do lots of things with this. But basically all you have to remember from dictionaries is that you have keys and you have values, and each key maps into a value. So the key cat maps into the value cute, and the dog maps into furry. And the way you do it is by using colons, and it looks a lot like a JSON array, a JSON object, for example. It's actually pretty much identical to a JSON object. And I just put in here like this in thing here, where I'm checking if a dictionary has a given key. So I can say cat in D says true, because cat is a key in the dictionary. So it's one way to check if a certain key exists in the dictionary or not. I could say, for example, if I said here something like horse, then it says false, because there is no key horse in my dictionary D. So this will give me false. And if I try to do something like this, then I get a key error, horse, because there is no key horse in the dictionary. So one way you can do it, something like this would be, it's a common pattern, is if horse in D, then print horse. If not, then don't do anything. There are other ways to do this, but this would be like one way of doing this without getting an error, right? You could also use exception, but anyway. Of course, you can assign values using the key. So I can say dfish equals wet, and then I have I can print it. So this, you can see here that you don't have to like explicitly add a key to the dictionary before you assign a value. You just assign a value and that's it. So I say, okay, dfish equals wet. I didn't have a fish before, now I have it, so I can print it, and it doesn't, it's super flexible, no problem. You don't have to do like, oh, new element or anything like that. And okay, monkey doesn't exist. We already talked about this. You can use del to remove something from a dictionary. So you can see in here that I deleted the fish, and then I cannot see it anymore. It doesn't exist anymore. Anyway, just all you have to remember about dictionaries is that you use strings to access them instead of integers, and that's it. I'm gonna jump over this a little bit because I really have to move on to other stuff. You can later just go open this notebook and see what you can learn, and send me questions later. But this is basically just showing you how you can iterate over elements in a dictionary, which is a little bit different than in a list, because a dictionary has keys and values, not only one thing. So It's a little bit different, but it's not that much different. You can take a look at that later. Then we have functions. This is also important. I have to go through that. You have for example, I defined a function here. In order to define a function, you write def, which it basically means define. Then you give the name of the function and the parameters that you're supposed to take in. So in this case, the name of my function is sine, and I'm taking parameter x. Then I said, okay, and then I said, okay, if x is larger than 0, then I say positive. Else, if x is less than 0, then I return negative. And then you can take a look. Maddie, I will give a link to all the notebooks and put them on the Moodle later, okay? Thank you for the question. You can see here this elif, which is like else if. Oh, sorry. This is the same. It's just a way to write, a more condensed way to write else if blah, 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 and then else, right? So you do it like this. Actually, this doesn't work. But anyway, if x less than 0, then I say negative, else 0. So it's either positive or it's else negative. So if it's not positive or negative, it's just 0. And this is a function, guys. So I hope this is clear. Again, all the same patterns as before. You use colons to define the block of code. You use indentation, and then you do whatever you want inside the function, and then you return some value so that you can communicate the returning value of the function to the outside world, let's say. And then in this case here, you can see I'm looping over these values here. So I say for each x in this list here, I want to know what x is and what's the sign of x. So -1 is negative, 0 is 0, and 1 is positive. And that's a very simple function, and you can you know, play with it later. One other very interesting thing with Python is that you have this possibility to do keyword arguments. So you can actually give names to the arguments and define that what are the standard values. So for example, in this case, I'm saying, look, if the user does not define loud, then you should define it as being false. So if loud, then print it like this. If not, print it like this. And then you can see here, for example, if I say hello Bob and I don't specify what loud is, then loud is assumed to be false. So you see that it works like this. And then later I can say hello Fred, and then I can do it like this. Loud equals false. No, sorry. Bodies has asked, do the returns have to be of the same type? No, you can return many different things. It doesn't matter. Python is really flexible in that sense. Whatever you return is considered to be the returning value. So there's no like restrictions of type to function. That's why you don't give any type to the function here. So here we have hello Fred, and then I say loud equals true. So I'm explicitly overriding this. I'm saying loud equals true, okay? This would also work. As you can see, I don't have to put the name here of the parameter, but I can if I want to. And the cool thing about putting the names of the parameters is that I don't have to worry about the order of the keywords here. Like for example, even though here I have name and then loud, if I actually specify that name is Fred and loud is true, then I can do it in a different order like this, and it still works just the same because I'm actually explicitly saying which parameter I'm talking about here, right? So that makes sense. I guess it's cool. However, on the other hand, if I do this doesn't work because I'm saying, look, loud equals true. And then I'm not giving a name, I'm not saying name equals Fred here. I'm just saying Fred. And this doesn't work because if I don't say the name here, then Python assumes that Fred is the second argument. And that doesn't work because I defined a keyword argument here, and then everything gets completely confusing. So if you define one keyword argument like this, then the rest must also be keyword arguments. I'm not gonna go, unfortunately, through that too much. You guys can play with that later, but it's just important to remember because we're gonna use that a lot. Like named arguments are gonna come up a lot. So just remember this, that you can do this. And the order doesn't matter as long as you define the names, the names of the parameters like this. And then finally, so I can move on, is classes. Again, like this would be, if I wanted to talk about classes, really, I would have to really talk 1 hour only about classes. But I just wanted to make sure you know how to call a class. This one, I won't even go over it anymore because we don't have time. But this is how you instantiate a class. So you basically just use the class name as a function and then call it. Give it the parameters that the class expects to get. In this case, it's a name. And then you can call class methods like this. Like so G now is an object of the class greeter. And then I can call g.grid. And then you can see here that basically it's just the same function that we defined over there, but it's now has it's inside a class. So basically when I say g.grid, I get hello Fred, because the Fred here has been saved as a class, let's say, property here, right? And there are lots of stuff that we could discuss about this. I will just leave it here and let you guys play with it later, because I need to move on to other more interesting stuff. But you can see here is the same thing that we did before with the strings or the lists. You have an object and you have a method, and then you call the method in the object. There are lots of stuff I have put here that are less important. There are exercises here that you can go through also if you want. Links for exercises. If you do them and you have problems, just contact me and I can help you.